Now let us try to understand in detail about distance formula. Consider the following three scenarios. First, consider 2 points lying on coordinate axis. Second, consider 2 points lying in same quadrant. Third, consider 2 points lying in two different quadrants. We are considering the above three conditions, or scenarios only, because any 2 points can lie either on the axis, or in the same quadrant, or in different quadrants. So now let's derive the distance formula, after looking into the examples. First consider 2 points lying on coordinate axis. Let's consider 2 points A is 4, 0, and C is 0, 3, on the coordinate axis. Let us now find the distance between the points A and C. From the figure you can see that OA equals 4 units, OC equals 3 units, and triangle AOC is a right angle triangle. So by applying Pythagoras theorem to the distance of A to C. Remember Pythagoras theorem, in a right angle triangle ABC, square of hypotenuse, AC, is equal to, sum of squares of other two sides, that is, AB, and BC. That is, AC's whole square, equal to, AB's whole square plus BC's whole square. AC's whole square equal to equals OC's whole square plus OA's whole square. AC equals square root of 3 square plus 4 square equals square root of 25 equals 5 units. Therefore distance between A and C is 5 units. Now consider 2 points lying in same quadrant. Let's consider 2 points P, 4, 6, and Q, 6, 8, in the same quadrant. Here they lie in the first quadrant. Let us draw P and Q as perpendiculars to the x-axis, from P and Q respectively. Also, draw a perpendicular from P on QS, to meet QS at T. From the figure you can see that, PRST is a rectangle. Therefore PT equals RS, since we know that parallel sides of rectangle are equal. Also from the figure we can say that RS equals OS minus OR. This implies RS equals 6 minus 4, this is equal to 2, this again implies RS equals 2. Therefore PT is also equal to 2, since PTSR is a rectangle, and PT equals RS, from the figure, QT equals QS minus TS. Equals 8 minus 6 equals 2. Therefore QT equals 2. Applying Pythagoras theorem, the distance between P to Q, can be written as follows. PQ's whole square equal to PT whole square plus QT whole square, equals 2 square plus 2 square, equals 4 plus 4. This implies that PQ square equals 8. This implies that PQ equals square root of 8, equals square root of 4 into 2. Therefore PQ equals 2 root 2 units. Now consider 2 points lies in two different quadrants. Consider the points P, 6, 4, and Q, minus 5, minus 3. When these points are plotted in the coordinate plane, we would observe that point P lies in first quadrant, and point Q lies in third quadrant. Now draw a perpendicular line to the x-axis, from point Q. And, also draw a perpendicular line to the y-axis, from point P. Make these perpendicular lines intersect at point T. From the figure you can see that PT equals 11 units, and QT equals 7 units. Applying Pythagoras theorem to the right triangle PTQ, we have PQ square equals PT square plus QT square, equals 11 square plus 7 square, equals square root of 170. Therefore PQ equals 13.03 units approximately. Now let us generalize the distance formula, based on the examples we have seen till now. Consider the 2 points P, x1, y1, and Q, x2, y2, as shown in the figure. Draw P and Q as perpendiculars to the x-axis, from P and Q respectively. A perpendicular from the point P on QS is drawn to meet it at the point T. Then from figure we can find that OR equals x1, OS equals x2, Also from the figure, we can say RS equals OS minus OR. This implies RS equals x2 minus x1. As RS equals PT, from rectangle PDSR, that is, opposite sides in a rectangle are equal, therefore PT is also equal to x2 minus x1. Remember that, here Q dash 0, y2, T dash 0, y1. When Q is extended onto the y-axis, it meets the y-axis at Q dash, and similarly, when T is extended onto the y-axis, it meets the y-axis at T dash. From the figure, y-ordinate of Q dash equals y2, and T dash equals y1, so distance between OQ dash equals y2, and OT dash equals y1. Also, from figure you can see that OQ dash equals y2. Therefore SQ equals y2, since QQ dash OS is a square, and OQ dash equals SQ. OT dash equals y1, therefore ST equals y1, since TT dash OS is a square, and OT dash equals ST. So, QT equals SQ minus ST. Therefore QT equals y2 minus y1. Therefore PT equals x2 minus x1, and QT equals y2 minus y1. Now we know the PT, QT values, so we can easily find PQ value. So by applying Pythagoras theorem, we can get PQ. Now applying Pythagoras theorem to triangle PQT, we have PQ's whole square equal to PT's whole square plus QT's whole square equals x2 minus x1 whole square plus y2 minus y1 whole square. Therefore, PQ equals square root of x2 minus x1 whole square plus y2 minus y1 whole square. The above formula is called the distance formula.